Hi everyone, in this video, we're going to dive deep into a fundamental data structure, arrays. Let's start by answering a simple question. What is an array? In programming, an array is an ordered collection of elements of the same type. Think of it as a list of items, where each item has a specific position or index, starting from 0. Arrays are a foundational data structure that allows us to store multiple values under a single variable name, making it easier to manage related data. While Kotlin enhances Java's collection classes with a richer API, and it's generally recommended to prefer collections by default, arrays still have their place, especially for performance-critical code or when interacting with Java APIs. Let's explore how we declare and initialize arrays in Kotlin. Code example 1, array of function, simple initialization. The simplest way to create an array in Kotlin is by using the array of standard library function. Let's type this out. Declaring and initializing an array of integers. Here, we've created an array named numbers containing integers from 1 to 5. Notice that we didn't explicitly specify the type like array_int. This is because Kotlin's powerful type inference system automatically deduces that numbers is an array int based on the elements we provided. If you want an array of different number types, like short or long, you might need to specify the type explicitly if the context isn't clear enough. Code example 2, array of nulls function, pre-sized with nulls. What if you need an array of a specific size, but you don't have the initial values ready yet? For such cases, Kotlin provides array of nulls function. Declaring an array of strings with a size of 3, initialized with nulls. This function creates an array of the given size, with each element initially set to null. We then manually assign values to each index. This is useful when you know the size up front, but will populate the elements later. Code example 3, array constructor with a lambda dynamic initialization. For more dynamic array creation, you can use the array class constructor directly, which takes 2 arguments, the array size and a lambda function to initialize each element based on its index. Creating an array of strings dynamically. In this example, array string 5 specifies an array of 5 strings. The lambda index a plus index to string is then executed for each index from 0 to 4, generating the values a, b, c, d, e. The index parameter in the lambda represents the current position in the array being initialized. Code example 4, empty array function, empty array. Finally, if you need an empty array, Kotlin provides a concise way to do that. Creating an empty array of longs. This creates an empty array of the specified type long, simple, and clear. Now that we know how to create arrays, let's look at how to interact with them. Code example 5, accessing elements and size. Accessing elements in a Kotlin array is very intuitive, similar to how it's done in Java or C#. You use square brackets with the element's index. Accessing elements by index. Index 1 refers to the second element. Getting the number of elements. The index starts from 0, so fruits gives us banana. To get the total number of elements in an array, we use the dot size property, just like with other collections in Kotlin. This is a nice consistency improvement over Java, which uses length for arrays and size for collections. Let's briefly touch upon mutability, a core concept in Kotlin. Remember val for read-only references and var for mutable references. How does this apply to arrays? Code example 6, val versus var with arrays. Using val for a read-only array reference. Compile error. Val cannot be reassigned. Modifying the content of a val array, still allowed. Using var for a mutable array reference. Allowed, the reference can be reassigned. When you declare an array with val, you're saying that the reference to that array object cannot be changed. You can't make fruits point to a different array. However, you can still modify the contents of the array itself, like changing fruits from apple to avocado. This is because val applies to the reference, not the underlying object state. If you use var, then both the reference and the contents can be changed. This distinction is important for writing safe and predictable code. Kotlin treats everything as an object. Even numbers like int or long are objects from a developer's perspective. However, for performance reasons and Java interoperability, Kotlin provides specialized array classes for primitive types. Code example 7, primitive arrays. Primitive array of integers. Primitive array of characters. Instead of array int, we have inArray for characters, char array, and so on. These include byte array, short array, long array, Boolean array, float array, and double array. These primitive arrays are more memory efficient because they avoid the boxing of primitive values into objects. An important detail to note is that these specialized primitive array classes, like intArray, do not derive from or are directly related to the generic array T-type. They are distinct for optimization purposes. This leads us to a slightly more advanced but crucial concept related to Kotlin's type system and generics, array invariance. Code example 8, array invariance. This function expects an array of any. If Kotlin arrays were covariant, like Java, you could pass an array string here, which would be unsafe. For example, data equals 123 would then be allowed, leading to runtime errors. Compile error, type mismatch, array string cannot be array any. To make it work, you'd need to explicitly define elements as any. This will compile. In Java, arrays are covariant, meaning an array string can be treated as an array object. This can lead to a runtime array store exception if you try to put a non-string object into an array string that was upcast to an array object. Kotlin avoids this by making arrays invariant. This means array string is not a subtype of array any. You can't just pass an array string where an array any is expected, and vice versa. This is a design choice that enhances type safety and prevents potential runtime errors at compile time. One common place you'll encounter arrays is in the main function, which is the entry point of your Kotlin application. Code example 9, main function arguments. Args is an array string that holds command line arguments. The args, array string parameter, allows your program to receive command line arguments. Even if no arguments are passed, Kotlin provides an empty array string, so it's always non-null. When calling Java functions that expect arrays, or using Kotlin's vararg syntax, arrays become relevant. Code example 10, vararg and spread operator. To pass an existing array to a vararg parameter, use the spread operator, asterisk. Vararg allows a function to accept an arbitrary number of arguments of the same type. When you already have an array and want to pass its elements to a vararg parameter, you use the spread operator asterisk before the array name. This unpacks the array elements as individual arguments. Finally, if you have a collection like a list and need to convert it to an array, you can use the toTypedArray extension function. Code example 11, toTypedArray function. toTypedArray function is a handy function for converting a list or other collections into an array T. And that wraps up our deep dive into arrays in Kotlin. We've covered their definition, various initialization methods, element access, mutability, performance-optimized primitive arrays, the important concept of invariance, and how they interact with vararg and Java. In our next video, we'll dive into Kotlin's next component. So see you guys in the next lecture.